Hey, Algebra 1 class, this is Mr. Biney coming at you with another day of notes. So today we are going to be talking about solving quadratic equations by graphing. So now that you guys have a hold on graphing, now we're going to be using that to find solutions to our equations. So the standard form of a quadratic equation, as it says right there, is 0 equals ax squared plus bx plus c. So we need to find all of the x values that make y equal 0. So what that looks like on the graph is when the parabola crosses the x-axis. So that can actually happen in three different ways. So normally if we have any old parabola that looks something like this, y equals 0 anywhere on that x-axis. That whole thing is y equals 0. So whenever the graph touches that, at that x value, so right here and right here, those would be our two solutions. So you can either have two solutions or another scenario is the vertex might be right on the x-axis. So like this green one here. If it's right on it and it goes and it increases in both directions, that means that's the only point that that graph is going to touch the x-axis. So in that case, we can have one solution if the vertex is on the x-axis. Or lastly, if we have a parabola that has a vertex above or below the x-axis and it opens up away from the x-axis, so this vertex is right about here and it opens up away from the x-axis, so up here would be another example of that on the other side. We have a vertex right here and it opens away from the x-axis. Those graphs, if they keep going on forever and ever, those are never going to touch the x-axis, so y will never equal 0. So in that case, we're going to have no solution. So now we'll dive into a couple examples. So now that you have some experience with graphing, you guys know the first thing we're going to do was from our first section of notes, we're going to find the axis of symmetry. So for that, I'll just call that AOS. We're going to take negative b over 2a. So again, we have ax squared plus bx plus c. So here, our a value is going to be the number out in front of x squared. So in this case, we have our a value is just 1. So if there's nothing out there, remember there's always a 1. And our b value is the number out in front of just the x. So here we have negative 10. So you have to be careful that you remember that negative goes with it. So we have negative b. So then the top will have a negative 10, which turns into positive 10, over 2 times 1, which is 2, and 10 divided by 2 equals 5. So our axis of symmetry, you always have to remember to write it as x equals 5, because that's the equation of a line. So if we go over to where x is 5 right here, this little dashed line that I'm drawing is the line x equals 5. So that's our axis of symmetry. If you guys remember, that's going to be the line that if we drew this on a piece of paper, which you guys are, once we draw the graph, you could fold it in half right on that line and it'll match up perfectly. Each side will be equal. So then from there, we have to find our vertex. And to do that, we use our original equation, except we're going to plug in this x equals 5. We're going to plug that in anywhere x shows up. So we start with an x squared. So we're going to make that 5 squared minus 10 times x. So we're going to make that minus 10 times 5. And then plus 24. So that's going to equal, these numbers you can plug into your calculator. but that'll be 5 squared is 25, minus 5 times 10 is minus 50, plus 24, and that's going to equal negative 1. So that's what my y equals. If you look all the way back over here at the start, y equals negative 1. So my vertex is going to be the x value, which is 5, comma, the y value, which is negative 1. So if we go over on our graph and plot that point, we're going to go over 5 to the right and down 1. So my vertex is going to be right here, that little red dot. So now we have 1 point, but we need a few more to be able to actually draw the graph. So in order to find those, we're going to make a handy-dandy little table of xy values, which we did when we were graphing quadratics. So our vertex is 5, negative 1, and we're going to pick points on either side of it. So if we go to the left, we're going to have 4 and 3, and if we go to the right, we'll have 6 and 7. So if you guys remember, we just take those x values, so we'll start with 3, and plug them in for x in the equation. So we have y equals 3 squared minus 10 times 3 plus 24. So this is just like when we were finding the vertex, except this time we're plugging in 3. And we can type that into our calculator, but I'll save you guys the time for the notes, and that should come out to be y equals 3. So I can put that back in my chart. Then if we type in 4, we're going to do the same thing. So y equals 4 squared minus 10 times 4 plus 24. And that one comes out to be 0. So we'll put that over here in our chart. Then we just got to plug in 2 more. So y equals 6 squared minus 10 times 6 plus 24. And that one's going to come out to equal 0. And then lastly, we got 7. So y equals 7 squared minus 10 times 7 plus 24. And that will equal 3. So we have that 6, 0 point and 7, 3. So each of these is an ordered pair. So to plot 3, 3, we're going to go 3 to the right and 3 up, and that'll put us right there. To plot 4, 0, we're going to go over 4 and up 0. That'll be right on that x-axis. 6, 0, we're going to go 6 to the right and up 0. And 7, 3, we're going to go 7 to the right and up 3. So if you look, those should match up perfectly across from each other across the axis of symmetry that we drew. So then to graph it, we're just going to take all of our points and make a little U shape, make our parabola. So remember from the top, our solutions are where y equals 0. So that's the points where the graph crosses the x-axis. So in this case, you can either look at the graph, and these right here are the 2 points where they cross the x-axis, or if you come back here over to the table, you can look at wherever y equals 0. So in this case, we are going to have 2 solutions. So our solutions are going to be 4, 0 and 6, 0. And then we're done. So now we'll move on to the next one. So again, just like always, we're going to start with our axis of symmetry, because that helps us get our vertex, which we need. So negative b over 2a every single time. Our b is negative 4. And our a, again, because there's nothing out in front there, is going to be 1. So we're going to have a negative 4 over 2 times a, which is 1. So we'll get a negative 4 becomes a positive 4. Those negatives cancel out. 2 times 1 is 2. And then 4 divided by 2 is 2. But every single time we got to remember, this is an equation. So we have to write it as x equals 2. And then if you just go over 2 and make a vertical line, this line you don't have to graph. I'm just putting it on there so you guys can see it. It's a little helpful. Then we'll find our vertex. So we're just going to take that x value of x equals 2, and we're going to plug it into our original equation that we started with wherever x shows up. So it's y equals x squared. So we're going to make that y equals 2 squared minus 4 times x. So we're going to make that minus 4 times 2 plus 4. And that's going to equal 2 squared is 4 minus 4 times 2 is 8 plus 4, which equals 0. So at 2, 0 is going to be our vertex. Then we can make our handy dandy XY chart to find a couple other points to be able to graph it. So if we have 2 is smack dab in the middle, that's our vertex, 2, 0. Then either direction we can go x equals 1, x equals 0. And to the right we can have x equals 3 and x equals 4. So now comes the fun part. We've got to plug these in. So y equals 0 squared minus 4 times 0 plus 4. And that's going to come out to be 4. So we'll plug that in the table. Then with 1, we're going to have y equals 1 squared minus 4 times 1 plus 4. And that is going to equal just 1. We'll put that in our table. Then with 3, just the same process every time. Plug that in for x. So we'll get y equals 3 squared minus 4 times 3 plus 4, which is going to come out to equal 1 again. And then last but not least, we got to plug in 4. So we'll have y equals 4 squared minus 4 times 4 plus 4. It's a whole lot of 4s. But wait, there's more. Turns out to equal 4. So if you guys notice, every time, as long as you go the same amount in each direction with the x, so from 2 to 1, we went 1. And from 2 to 3, we went 1. And you can notice that the y values are going to come out to be equal, as long as you move left and right the same amount. So then from 1 to 0, we moved over 1. And from 3 to 4, we also moved over 1. And look at that. Our y values are the same again. So where that comes from is, if I quick graph these points, we're going to have the point 0, 4. So over 0, up 4. And 1, 1. So we're going to go over 1, up 1. We'll have 3, 1. And 4, 4. So if I quick just sketch a graph of that bad boy. So what I was trying to explain before is how these points line up straight across from each other and they have the same y value. That's the exact reason of why we find our axis of symmetry. So if we fold it over, they should be lined up perfectly. So if you find just these first ones and you find the y values, the 4 and the 1, as long as you went the same direction when you went to the right of 2, I'd be fine if you just wrote in this 1 and this 4, if you can make that connection and realize that. So you do still have to do for sure these first 2 steps up here, but you can skip the second 2 as long as you go the same direction, or the same amount in the other direction. All right, so we'll do the last example on the next page as a warm-up tomorrow. Have a great night.